Find the volume of the solid obtained by rotating the region bounded by y equals 7x plus 28, y equals 0, x equals 0 about the y-axis. So I think the first thing we need to do is be sure that we're on what we're actually trying to do and what it looks like. Now, I hope that you know how to graph the line y equals 7x plus 28. But I can go to Desmos, start graphing. So I can just type y equals 7x plus 28. Can't see the whole thing, so I can zoom out. So I'm looking at a triangle. I just need a sketch of that curve in order to get started on understanding what this is going to look like. So that is y equals 7x plus 28. This is y equals 0. The x-axis is where y is equal to 0. Y-axis is where x is equal to 0. And this line that I'm going to draw in red is y equals 7x plus 28. So what we're talking about is taking this region that I'm about to shade in red, this triangle, I'm going to rotate it about the y-axis. So I want you to take a minute and think about how you would describe this in words. Pause the video and you can come back. I hope you actually did the exercise. This is going to be a cone sitting on the x-axis, or whose base sits on the x-axis. And now our job is to find the volume of that cone. We want to think about what cross-sections look like. That's always the question that we have. A cross-section here is going to be a circle. I'm slicing my cross-sections this way, perpendicular to the y-axis, because that's the way I'm rotating. Up as an integral with respect to y, if I know the area formula in terms of y, I can use this formula that we developed where I'm integrating something. Now if I look here, this circle that I'm rotating has an area, the radius is x. The radius of this circle is equal to whatever the x value is at this point. I'm looking at a circle that has a radius going this way of x. I wanted to express that in terms of y. And so I can use the fact that y equals 7x plus 28 to solve for that. I want to solve this for x so that my expression is in terms of y. If I do that algebraically, I get x equals 17 y minus 28. This circle has a radius of 17 y minus 28. Well, the area of the circle is going to be pi r squared, and I've just figured out that the value of r. A is equal to pi times 17 squaring the radius, so this whole expression. And so I just need to integrate that, but I'm leaving something out here. And those bounds need to be coming from the shape that I'm trying to create. I should be integrating from point at y equals 0, this point, where the triangle that I'm rotating stops. Well, how do I know where to stop? Well, this point is the y-intercept of this line. You agree? X is equal to 0 at this point. So if I plugged in x equals 0 to this equation, I would get y equals 28. So my bounds of integration here should be from 0 to 28 of this function. So the final calculation would be the integral from 0 to 28 pi times quantity 17 y minus 28 squared dy. I could calculate this out and FOIL it out essentially and keep going with the fundamental theorem of calculus to find an antiderivative, but I'm going to ask Desmos to do it for me. If I just type int, it automatically creates the integral symbol, and I can use my arrow keys to navigate. I have to be able to type this in correctly, but if I do that, I can get the answer. A relatively large answer. So I would take all these decimal places, and it should be good. Let me know if you have any questions about that. Most important part of the problem is being able to set it up by fighting through the shapes that you're dealing with and reasoning through what the area of a cross-section should be.